Welcome to video 3 in our course B09 Introduction to R. Now we're going to talk about getting data and exploratory data analysis, which is covered extensively in the other course, ST9 Exploratory Data Analysis. So in this instance, what we're going to think about is key packages that help us organize our data, like tidyverse, ggplot2 for visualization, dplyr for data manipulation, readr for importing data, um, and these things make it much more easier. We're going to use the umbrella package tidy models, which can links to a series of packages we're going to use. R sample that splits our data into the tre training, testing, and sometimes validation data sets. Recipes that allows us to pre-post the data. Parsnip that fits the model and helps us make predictions. And yardstick, which helps measure model performance. And workflows how allows us to bundle different recipes or models together. And tune allows model optimization. So they're all in the tidy models package, which you just need to install on its own, not all 6 of them. So our goals will be to get the raw data using the package tidyverse to convert it to a form that's useful for us, to apply exploratory data analysis, to explore linear models in using just base OR methods, to split the data into testing and training data sets using R sample, to pre-process the data using recipes, to fit the model using Parsnip, evaluate the model performance using Yardstick, and that kind of is our where we're going with this. So we're going to use features like the colony size, growth rate, and zone of inhibition in a set of treatment-resistant and treatment-sensitive bacterial samples. We're going to model that data and predict that they're either going to be resistant or sensitive. So we have existing known data on whether the resistance are sensitive, and we're going to extract information from this data to make that prediction to see if that corresponds. So we can apply these kind of approaches to many different questions. For example, you might ask, is the minimum inhibitory concentration of sample species A different from species D? One way of doing that statistically, we just simply use, I guess, the forms of linear models, t-test and ANOVA on that. You might ask, do my isolates group into natural groups, where I might use some sort of unsupervised clustering technique to assess that, such as PCA. Um, when we have more substantive questions like which 50 genomic features best explain the MIC level, we might use something like regression or such as lasso. Um, and then we might have questions like, can I predict resistance from just 20 features, where we apply our example later of machine learning based supervised classification models. So that kind of is at the end of this video. Please see the next one on linear regression.